Welcome to Spring LIB.
Okay, so we have a product and we've got to predict what the reactants were. So we've attached, it looks like a benzene ring right here. That's what C6H5 represents. We've got a wedge to a methyl group here and a dash to an OH. And then on the backside, a couple methyl groups. Now, you've correctly identified what the epoxide, actually, I'm not so sure that's the case. Okay, so basically, this was previously an epoxide, but then there was backside attack of an organometallic reagent, this case C6H5. So maybe it'll help if I draw this out a little differently, and you can see, in fact, what this C6H5 actually looks like or means. Right, it's like we've attached a benzene ring. Okay, and so basically what I'm going to do is say, okay, cut this off here, and the organometallic reagent that corresponds to that would be something like a Grignard reagent, MgPr, like so. So this is our organometallic reagent, and I got that by disconnecting this bond, right, neighboring the OH. Okay, and then to figure out what the epoxide looks like, I'm going to imagine that we've, instead of having an OH here, that the neighboring carbon, rather than being attached to this benzene ring, is attached instead to the oxygen. So I'll simply redraw the substrate. And I will have a dash to an O to an oxygen on either side here. Right, and so basically this would be the epoxide, and the way that this reaction would work out is that if you want to see the mechanism, which is not really part of the problem, here's your final answer. This is your organometallic, this is your epoxide, but if you're curious how this works, recall that if you have an organometallic reagent and an epoxide, that the bond between the carbon and the bromine will break and attack the carbon, one of the sides of the epoxide, and it'll specifically attack the back side of the carbon-oxygen bond. That'll swing up on the oxygen, and so when you're done, you'll get, if you had a dashed oxygen, you'll get a wedge to your new substituent, and if you had a wedge, you would get a dash. But there you go. So yeah, make sure you flip the wedges to dashes in your drawing of your epoxide, and then your organometallic reagent is you don't want to have the whole rest of the molecule like you have.